Hi everyone. Hello. Hi everyone. Can you guys please confirm if am I audible? Hi everyone. Can you please confirm if am I audible? Please drop a message in chat. Hi Priya. Priya, can you please confirm if I'm audible? Okay. We can wait for 5 more minutes for everyone to join. Okay, thank you Priya. Hi everyone. Good evening. Good evening everyone. Can you all please confirm if I am audible? We can now start the session. We are already 5 minutes up. Can you guys please confirm if my audio is good? Hello guys. Yeah. Hi. Hi Kuruma, the beast, Naruto guy. Okay. Yeah. So we can start the session. Thank you for joining Kuruma, Priya, everyone who is live. I'm not able to see your names. Okay, so today we will be discussing a very, I would say, nice topic, means nice to have topic. Hi Vikas, hi. Yeah, yeah, thank you everyone for good response in previous video. Uh, yeah, oh, hi Vivek. Yeah. Yeah, thanks, Vivek. Thank you everyone for we crossed 1K views in the video, and we also have 1K subscribers now. So yeah, I'm glad that you guys are liking the session, and that's why I'm motivated more to have this session right now. Yeah. So yeah, maybe we can start with the session. It's already late. Yeah. So we must have heard about the things like ASIC, FPGA, everywhere over the VLSI अपन को ये सुनने में मिलता है कि ASIC है, FPGA है, I am working on this ASIC, I have worked on this FPGA. Usually students बोलते हैं कि हमने इस FPGA पे काम किया है, this FPGA. Yeah, thanks Vivek. So let's discuss what's the basic meaning of ASIC and FPGA and how these two are different from each other. Okay, so let's move on, and you guys can interrupt me anytime with any questions. Yeah, I'll be happy to answer them. Okay, so this is just a bit about me. So I'm Pratyush, and I guess you guys already know me. So I'm Pratyush, and I have done my master's from IIT Bombay in Integrated Circuits and Systems. And currently I'm working as ASIC engineer in Nvidia, and rest all journey I had that 70 rank in gate and was selected as ISRO scientist and cleared several PSU exams. Yes. Okay, so let's actually start with the session. Okay, so just a quick question. What are chips made of? Okay, I guess Vikas is live, so maybe he can tell. What are chips made of? Do you have any idea? Okay. Okay. Anyone live has any idea? Oh, great. Yeah. Silicon. Yeah. But that's a very high level. Okay. Yeah. But okay. So, in simpler words, chips are like brains to the gadgets. So, whatever you have, तुम फोन पर इंस्टाग्राम स्क्रॉल कर रहे हो, you are watching something on laptop, you are browsing through Netflix. Yeah, yeah, yes, really. Some electronic design in silicon wafer. Yeah, yeah, great. Yeah, thanks for the response. Yeah. So, uh, in all these gadgets, what is the brain that is working behind? So think it of as of an human body. आपका human body है, so you have a brain, so that is controlling everything. Yeah, yeah, Priya, thanks. So that is controlling everything. But your hands, legs, these are the peripherals to your brain, right? Brain is using them. Yeah. So that's how the chips are to the gadgets. So let's start. So inside these chips are not simpler. These are pretty much complex, but we as an engineer make them simple. Okay. So these chips, in simpler words, are just tiny logic gates. So you guys must have known about some of the logic gates in your college. So just like AND gate, OR gate, NOT gate. Yeah. So using these logic gates only, chips are made, and these serves as a brain. So they don't have brain actually. We are the ones who put in the brain. Yeah. So that's how chip are made. But how do we build them? The real question arrives here. So there comes the role of what we say and what is FPGA. So that's what every engineer who wants to understand. Okay, so let's start. Hi everyone who joined later. Sorry, I started the session earlier. Okay, so yeah, maybe you guys can look into the rest of the session. Yeah, this thing, Venkata. At the end of the session, these kind of questions I will take care. Okay. Yeah. So, okay. So now, as we understood the need of FPGA and ASIC, so what is FPGA? Okay. So FPGA here stands for Field Programmable Gate Array and blah blah. These are just theory stuffs. Okay. But what is it in exact words? So everyone here would be familiar with Lego blocks, right? Uh, yeah. Can you guys please confirm if I'm audible? Yeah, yeah. Okay. So yeah, so FPGA. So everyone here would have known the Lego blocks, right? Hi Neha. So what basically Lego blocks are? These are just building blocks, right? And you arrange them in some pattern so that they make sense to the viewer. Let's say you want to construct the building, means just a tiny building for playing purposes. So you arrange the Lego blocks in the format that they come together to form a building. So on a very basic level, we can understand FPGA like that. So you have bunch of, instead of Lego blocks, we have some similar word called logic blocks. So in FPGA, we have logic blocks, and in such a way, means we use them instead of arranging, we use them in such a way they are showing a picture of something we wanted to build. So let's say you want to build a smart adder kind of thing. You want to build a calculator and you want it through hardware. How would you do that? So okay, you have FPGA for that. So let's say Neha, Vikas, they are both are working and they don't have access and money to for ASIC design or for something. Oh, okay. Sorry, Neha, I will take care. Am I audible now? Yes, please confirm if I'm audible. Now my voice is fine, right? Okay, okay. Okay, so let me start. So let's say Neha and Venkat both are working on some project. Okay, and Neha wants to build a adder, and Vikas want to build a subtractor, but they only have one hardware. Okay, how will they do that? They can only build one hardware. So that's where the need of FPGA comes in. Okay, so Neha want to test the adder, Vikas want to test the subtractor. So what they do is they take an FPGA. So first Neha build an adder on that FPGA, test it, verify it, and then give it to Vikas. Okay, and he build an subtractor. So FPGA is a thing. Means FPGA, you can make anything out of FPGA. Okay, so you would be like, sir, we have this much powerful thing. Why we are going for ASIC? Why I see in every company ASIC is there, ASIC is there. Why don't we only work on FPGA? So just like Lego blocks, they give you a dummy building, right? Those are not actually building you can live in. So similar to that thing, FPGA are just for learning and testing purposes. So don't think that it is not very important. So in industry, actually FPGAs are used for testing out some design which a designer is trying to put in. Okay, because for ASIC the cost is very high. We will come to that. Okay, yeah. So FPGA is general. Yeah, correct, Vikas, correct. So FPGA is general purpose. So whatever I want to make, I can just code it in FPGA and it will work. And the same FPGA I can give to someone else and he can code something else. So FPGA is scalable and general purpose and is best for learning purposes. Okay. So let's go to ASIC. So ASIC stands for Application Specific Integrated Circuit, and still it's just a definition. But as the name suggests, Application Specific Integrated Circuit, which means that you have an application beforehand, and for that you make an IC that is called an integrated circuit. Okay, so let's say again Vikas and let's say Priya are working on some project and they have same idea from the start. Okay, and that's a very good idea, and they wanted to bring out a silicon out of that. So what they will prefer is having an ASIC, and I will list out what are the advantage. But yeah, uh, means just consider this point, like a custom built robot does only one job, but it's fast. Okay, so consider of a robot which is working on many jobs, which can do cleaning, which can do your laundry, and which can turn on TV or something else. कुछ भी कर सकता है. Okay, but it will not be very fast to response. मैं बोलूँगा कि भाई washing machine जाके देख ले. Then he will process what the user is saying, and then he will go to do that work. But if I have a bot just to do a single thing, then he will be fast, right? Yeah. Yeah, application specific. Yeah, Vikas. Okay. So that's the purpose of ASIC. So you got the difference, right? ASIC will be fast, but FPGA is for general purpose. Okay. The the drawback with ASIC is once it is built, it can't be changed. Okay. So you build anything on silicon as an ASIC, you can never change it. So consider the mobiles or the laptops you are watching the video on. अब उसमें जो चिप लगा है, let's say processor, in mobile let's say आपका Qualcomm Snapdragon something blah blah series 8 gen series है, okay, that processor is fixed. अब आपका मोबाइल में सॉफ्टवेयर अपग्रेड होगा, but hardware will not be upgraded. For upgrading the hardware, you will have to buy a new mobile. That is the disadvantage of ASIC. Okay, you can't change any functionality. Once it has come in silicon, then you have to accept it, however it is. So ASIC finds a wide usage in real world because of its speed and reliability. But FPGA found its way to the testing and every other thing. Okay, so please let me know if anything I'm missing out, or you guys need to know something, or you guys are not able to catch up with something. Uh, Vikas, Priya, Bhuvneshwari, Neha, Venkata, प्लीज एक एक बार कमेंट कर दो यार पता चले तुम लोग लाइव हो थैंक्स थैंक्स विकास थैंक्स okay, okay, waiting for your response guys. Okay, Priya, thanks. Okay, okay. Let's. Okay, sir. How does it work? Vikas, you're talking about ASIC or FPGA? Vikas, sorry. Okay, okay. I will fix it in next time. I don't know, some network instability is there. Video, it is not turning on currently. If reset time of any module in chip has to change, can't we do it through? Yeah, Bhuvneshwari, whatever signals which you have outside the chips that are solely in your control, that you can do through software upgrades. But I'm not sure what reset time you are asking. Is it in regards of your mobile? So the restart time you are saying. So since I'm not very sure how to answer this question, but yeah, in general, so your mobile just don't have only the processor. It has many other things. Okay, and many other things I'm talking about. Each of these things are hardware and are ASIC. Okay, so each has its own functionality, and each will have a delay. So I guess, yeah, yeah. So I guess that won't be, that can't be changed by a huge margin. But yeah, software updates can improve your mobile phones. So software update mostly involves the post processing stuffs. Okay, but hardware side they can't do anything. Okay, how FPGA can be used for. Okay, 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 okay. Yes, Vikas, I will tell you. So the thing is, okay, so can you look at the, is my screen visible? I'm on FPGA side, actually. Please let me know if it is visible. Okay. So in FPGA, yeah, okay, thanks for mentioning. Okay. So in FPGA, there are different logic blocks which are present. Okay, and these all logic blocks are programmable. Okay, so consider these of as wires. So a user can means not the user, but there is a when you write a design file and you give it to the synthesis tool, like let's say you are using Quartus for synthesizing your design for an Intel FPGA module. So what it does is it generates a bit file, a series of zeros and ones. Okay, and those zeros and ones come to these wires. Okay, and these wires program the logic. Okay, and this programming is done in such a way that it programs the FPGA for your purpose. Okay, we will have a very good detailed session. So maybe I can plan another session in which I can show you how FPGA synthesizes your code and how it programs the logic blocks. Okay, we can do it if you guys are interested. If I get good responses, we can definitely do that. Yeah, I would be interested to do. Okay, so essay it programs the lines. Yeah, and through these lines, the logic blocks are programmed, and you are able to uh, see your results over FPGA. Okay, am I clear? Because okay, so okay, thanks, Vikas. Yeah. So I have made a quick comparison between both the things which we talked in today's session. So FPGA and ASIC. Okay. So just a quick summary slide or something kind of that. So okay, what can change later? So as we already discussed many times, FPGA can change later. Yes, many times. Okay, based on users requirement it can change any number of times, but coming to AC, they cannot be fixed ever. They cannot be. Okay, so this is one thing. AC is like your mess ka khana. Cannot be changed. Okay, so yeah, so speed in FPGA you will get good speed. Okay, but in ASIC you will get the super fast speed. Okay, so FPGA, as we already seen, either other logic distributed, right? So you won't get very good speed, you won't get the optimized logic, but in ASIC एक ही चीज है, you have to work on one thing only, so you will make it perfect. Okay, so it will have a very high speed. Okay, so yeah. So the next thing is cost. Okay, so you guys must be wondering, like, here, sir, you have written cost is higher for FPGA and cheaper for ASIC. बट आपने तो बोला कि एफपीजीए को अपन एक्सपेरिमेंटल पर्पस के लिए यूज करते हैं. सो कॉस्ट फॉर एफपीजीए per chip is higher. Okay, so that is because FPGA का production is not very large scale, huh? And it has a huge amount of logic. So एक FPGA board is as big as your laptop screens, but एक ASIC is very small. Okay, so comparing ASIC versus FPGA, so FPGA, so that the large screen I was talking about the FPGA board, so it has other peripherals also. But talking about the FPGA chip, it is smaller. But as compared to ASIC, it is still bigger in size because it has lots of logic gates for user. Okay, ASIC is some optimized thing. Okay, that will have only that number of logic gates which are needed for that purpose. Okay, so in general, cost of FPGA is making cost of FPGA is higher, but yeah, once the FPGA is made, you can use it for n number of purposes. Yeah, mass production, so less cost per chip. Yeah, you got it, Vikas. Thanks. Yeah, so that's it. And next point is time to build. So आप ऐसे ही सोच लो कि एक जगह आप एक रॉकेट बना रहे हो और दूसरी जगह कुछ एक जनरल पर्पस कंप्यूटर या जनरल पर्पस कोई चीज बना रहे हो. So the time to build for rocket will be very higher than some general purpose thing, right? And you don't need that much precision, that much accuracy. Okay, so I will tell you one thing. Uh, Pura industry works on three principles. PPA. VLSI industry में, if you guys know, मतलब this is a very famous term, PPA. Can anybody tell what is the full form of PPA? Anyone? Vikas, Bhuvneshwari, Priya, Neha, Venkat. Okay, ठीक है. So the full form is power, performance, and area. Okay. Yeah, yeah, Vikas. So full form is power, performance, and area. तो पूरा VLSI industry इसी के पीछे भाग रहा है. So you have to reduce the power, you have to increase the performance, and you have to reduce the area. So इतना सारा कंस्ट्रेंट के बाद अगर ऐसे कोई बनाएगा, so it will require time, right? So that's why it require good amount of time. और इसीलिए मतलब someone could have come up with an argument कि भाई ठीक है, मेरे को एडर चेक करना है, मुझे सब्सट्रैक्टर चेक करना है, मुझे ये चेक करना है, तो सबके लिए एसी की बना बना के चेक करता हूँ ना. व्हाई डू आई नीड एफपीजीए? सो दैट इज द टर्न अराउंड टाइम. सो इन एफपीजीए वंस यू गेट द चिप, तुम कुछ भी उसमें डाल के चेक कर सकते हो. विद इन वन डे you will be able to check your design. But in ASIC, you would require several months to make it to the production. Okay, yeah. So yes, Vikas. Yeah. So there are the trade-offs for efficiency. Yeah, yeah, you got it. So yeah, so best for FPGA is best for prototyping, fun ideas. Okay, Vikas have some idea. Okay, I can make this kind of adder, make this kind of let's say your making some processor. You can try a lot of things. Okay, and so I will include these things a lot in FPGA, how to prototype and how to design, and we will learn a lot of new technologies. So the hardware coding is not just limited to only hardware description language. Now we are going way beyond. We are even using the general programming languages also to program the hardware. So yeah, that will be very good. Huh? No, no, no. Yeah, Bhubaneswari in other sense, yes. So if you have some logic, so first you put it in FPGA and check it if it is working, and then you go for ASIC. Yeah, 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 yeah. Yeah, that's the design process. Okay. So after every design, actually there are teams even in our company which put uh, these designs into FPGA and check so whether it's working fine or not in hardware. So yeah, that's a good point. Yeah, thanks, Bhuvneshwari. Yeah, so yeah, we will be learning a lot new things. So I hope you guys stay tuned with me. Looking forward to hear from you guys. Okay, and I don't know if Venkat is live or not. Venkat, can you drop a hi or something in the section so that I know and then I can answer the question? Or if someone has the same question, I can answer it here only. Anyone guys, थोड़ा कमेंट करो तो फीडबैक मिले मुझे क्लोज लूप सिस्टम बन जाएगा अच्छा काम करता है ना क्लोज लूप सिस्टम स्टेबल रहता है विकास भुवनेश्वरी प्रिया anyone can you comment and confirm okay okay Priya this session, yeah, I wanted to stretch this session more, but I will have another session, Bhuvneshwari, uh, probably tomorrow. Due to some time constraint, I could not extend the slides for this session. We will have an extension of this session only. Tomorrow, you guys tell me what is your comfortable time. We can have session tomorrow as well. I will come with more good concepts of FPGA and ASIC. Maybe we can discuss broadly about the FPGA flow and ASIC flow. You guys please comment what is your suitable time. Yeah, thanks, Bhuvneshwari. Oh, thanks, Vivek. Thanks, Vikas. I will share. Yeah, I will share the resources to learn VLSI. But yeah, for now, means we will be launching the uh, this VLSI course very soon, and we will be starting right from the basics. So yeah, Stay tuned. Okay, I guess Venkat to chala gaya, but yeah, I can answer the question. But where will I say placements and what exactly to cover? Yeah, so Venkat, just to say, means answer your question, uh, there is a lot to learn for VLSI placement. So everything starts from digital electronics. So yeah, what will be the duration of the course? Yeah, currently because the duration I have not means I have designed the course, but duration I will let you know in tomorrow's session probably. We will also be having a separate launch in which we will discuss the exact duration or something like that. But yeah, it will be a long course, and what I'm thinking is you guys also can suggest what could be better. But the current plan is I'll start from basics, and you guys will learn everything from the basics, and then for digital, I will be taking uh, all the classes for all the VLSI concepts, and we will be doing a lots and lots of projects, including FPGA and ASIC design. So I have some tool handy for ASIC design as well and for FPGA. So yeah, we will be doing lots and lots of projects, and I'll be filling out your resumes with lots of projects actually. Oh, you did digital and microprocessor. Okay, so you did digital codes, right? So, yeah, okay, yeah. So maybe for okay, Verilog also you have done. So maybe first have some grasp on networks also, and do a lots of RC problems, and then learn. I would not say learn full EDC, but yeah, in the end you will get a lot of sessions of MOS basics and learning those. Semicon means those CMOS technologies. Yeah, so you can start with that portion of EDC, and yeah, by then we will be launching the course, and yeah, we will be good with that. So you can join there directly, or yeah, anyways, we can connect, and I can share you what to do next. Anyone else have any question? Vikas, Bhuvneshwari, Priya, Neha. I don't know who else is live. Sorry, guys. Okay. So yeah, if you guys don't have any question, we can end the session currently. And thank you everyone for joining it. Much appreciated, guys. I hope you like the session, and थोड़ा सा feedback बता दो so that I can also improve later. Okay, guys, if you don't have anything, maybe we can end the session here. या विकास ठीक है बता दूंगा आई विल लेट यू नो टुमारो ओके थैंक यू एवरीवन थैंक यू एवरीवन लाइव थैंक यू फॉर joining थैंक्स विकास थैंक्स प्रिया थैंक्स नेहा थैंक्स भुवनेश्वरी yeah I'll notify about the timings